Good morning, everybody. The last day you had a class, I gave ye the 2019 higher level question 6 passive house design question to do, and I just want to go through the solution to that and anything else that may have arisen. Now, the question itself didn't actually mention the word passive in it. If you actually look at it, it says that the elevation and ground floor plan of a house are shown. The house has 2 bedrooms, a bathroom upstairs. The external walls are of timber frame construction with a rendered concrete block and timber cladding finish. The house is designed to have a low environmental impact. It is that phrase, low environmental impact, that should have set the alarm bells ringing in your head there, that this is a passive house. Now, if we are talking about a passive house, we are talking about a house that is designed specifically to save and be neutral in terms of its electricity use and heating costs and other areas within the home. So what we were asked to do then is we were asked to, with reference to design shown, discuss using notes and freehand sketches 3 features of the house that contribute to that particular house having a low environmental impact. Then we were asked, and by the way, there's a lot of bits within this question that are easily missed, to the point even where I was doing it a while ago, and I thought I was going to be finished about 20 minutes before I actually was finished because I had forgotten an element of it. Anyway, part B says, using notes and freehand sketches, discuss in detail each of the following renewable energy technologies and identify how each contributes to making a home more eco-friendly. That's the bit I nearly forgot. Identify how each contributes to making the home more eco-friendly. And the 3 items it separates out or discusses are evacuated tubes, wind turbines, and photovoltaic panels. Okay, so we need to talk about them. And then the last bit then was discuss in detail 2 advantages of using local craft skills on building the house. Now, the issue with that particular element of the question is the potential for waffle is massive. So we need to kind of pin down how exactly that should be written out and how it should be discussed in order to generate marks. All right, so moving on to the first bit. So first of all, we have to look at the drawing that they gave us, and we have to basically go look for clues to things that make this a low environmental impact house. So the first thing I wrote down was, I said the house has a large south-facing, glazed windows and doors to allow maximum sunlight to enter the house naturally. Okay, so if you look at the diagram, and actually I'm going to go on to the diagram on the next page. If you look at the diagram here, all the large windows are to that south-facing front elevation of the house. They're all down here at this side. And our sunlight is coming, well, first thing in the morning, there's our north, south, east, and west. Our sun travels from east to west, so our sun is traveling over here to this side throughout the day. So anything at this side of the house is going to be sunny and bright and warm, and the house will gain heat because of that. Whereas the opposite is true at the back of the house, and even this side here on the east, there's one small little window on the back of the house, in order to minimize losing heat from it being north facing on that side. Okay, so that was the first thing I wrote down. So what will this do then? Okay, so why was that important? This will help to heat the internal space, which reduces heating costs and the dependency on non-renewable fossil fuels. Okay, aim of the game here is not to have to use non-renewables such as oil and coal to generate heat or whatever for a house. Now, next thing I wrote down then, and I've used one major diagram, by the way, to kind of talk about everything that I want to highlight. So the next one I've written down then is that trees in the south side, what do? They provide natural solar shading during the summer months. So this is to help to prevent overheating. So and they reduce that. Now, if you look at the trees where they are positioned, they are, yes, giving you natural shading, but they're also not quite right up against the house, so they're not covering over the windows or the large windows that are getting sunlight. Okay. Next thing I put in, I said, look, there's a wood burning stove, and what does it do? It contributes to the reduction of drafts associated with an open fireplace. A wood burning stove, remember, is a closed unit. There it is there in the center of the house, and it helps reduce drafts because of that. Okay. I just want to check one thing. Yeah. Now, next thing I wrote then, I said there's a high thermal mass chimney stack. Now, what does that mean? That's basically about the location. It's located centrally. Okay, so it's a modern chimney stack, so designed to the highest specifications, but located centrally, so the maximum heat can be retained and not lost to an external wall. This is very important. There's our chimney stack in here, right in the center of the room. So any heat generated from it is going into that open plan room. It's not on an external wall. If the chimney was back there on the external wall, half the heat would be to the external side. It would be outside literally, and you would lose heat because of that. Okay, so located centrally, so maximum heat can be retained and not lost to an external wall. There's also high levels of insulation in the walls, reducing heat loss. We always say that. We know now at this stage modern levels of insulation are much higher. Now, I also said that the north elevation has smaller windows to reduce heat loss and conserve energy. So I mentioned that a minute ago when I was talking about the fact that there's big front elevation windows. The north elevation, the north side, has only one small little piece of glazing. Remember, we lose heat through windows as well, particularly if they're north facing. So the bigger the window there, the more loss of heat. Now, there are photovoltaic cells. Actually, I spelled that wrong there. Photovoltaic cells on the roof, and what do? They generate. Sorry, now what am I doing here? They generate renewable energy. VOL. Now let's just fix this. VOL. Oh, wrong color. VOLTAIC. I left out the. Anyway, photovoltaic cells on the roof to generate renewable energy, and you can see them just there. Okay. Anything else there in the diagram that I haven't mentioned? Oh yeah, and I never wrote this in the notes really. The main living area, if you look at it, is south facing. So where you're spending the majority of your time is your main living area, and it is south facing. Okay. Now, we were then asked to explain and show how 3 different elements of a passive house design will work and ways of generating electricity. So the first one we're asked to talk about was evacuated tubes, which are basically, what are they? They're a solar evacuated tube collector. They're designed to collect heat from the sun in order to generate heat for your home and electricity for your home. Now, these basically are made up of 2 parts. The first part of the evacuated tube is a thing called a heat exchanger. Now, that heat exchanger is located on the top. Okay, so heat exchanger we're talking about here. It's located on top of the collector, right? And the cold fluid coming from the solar storage tank is heated up, okay, as it travels through the piece and transferred back to the solar tank as a warm fluid in a continuous cycle. Where's my diagram for this? Here it is. Okay, so let's look at the diagram for a minute before we go back and read the stuff. Okay, so photovoltaic cell, right, here they are. These are the evacuated tubes, okay. Sorry, I shouldn't have called it photovoltaic cell there. It's an evacuated tube. What does the evacuated tube contain? Well, it is evacuated of air in order to make it more efficient. It contains a heat pipe, which is made of copper. And then you have your absorber plates underneath the heat pipes made from copper. Okay. Cold water comes in here into the manifold. It's a copper manifold. This is where the heat exchange takes place. And a heat transfers that hot water out, because each individual evacuated tube is generating heat using solar radiation. So solar sun creates this heat transfer and it allows a heat exchange to take place. And we get cold water in and hot water out. Okay, so individual evacuated tubes, right? What's the story with them then? So each individual one, they can be attached or removed from the heat exchanger without affecting the overall functioning. Why? Because fluid within the manifold and the individual tubes are on a separate system. So in other words, you can screw and unscrew these evacuated tubes here one by one in order to replace or fix, and you won't mess with the system. The system will still work. Naturally enough, the less tubes you have, the less heat you have, the less efficient the system. Okay. Second part of this question then, or second part of just explaining individual evacuation tubes. Each double-walled round tube has a hollow copper pipe inserted through the length of the tube. There is a vacuum between the glass and the copper pipe. So that's where your vacuum is. And what does that do? It acts as insulation against heat loss. Okay, so that's acting as acting as insulation against heat loss. Now, these tubes can be attached or removed easily, and the more tubes you have, the better the system. Makes sense. Okay, so there's our diagram. You will need to be able to draw something similar to that, certainly with the detail needed of each piece. Now, we're on to the wind turbines. So the second element they wanted us to talk about or discuss was the wind turbines. And effectively, the turning of the blades on the rotor is activated by wind. So what is a wind turbine? It's basically a big windmill type thing. Only mill is the wrong word. It has three blades which are activated by the wind. The wind spins the blades then generate electricity. But well, what actually happens? So what happens is they spin the main shaft and the gearbox, which spins the generator, and that generates electrical output. So it's the spinning, it's the generating. It's like a dynamo on your bike. Okay, it's generating electrical output. They can be connected to the batteries or they can be connected to a national grid. So you may have a wind turbine that's on the national grid, or you may have a wind turbine that's going to a house, which is generating charge on a battery within that house. Maybe the house is using that charge. Maybe the house doesn't use all of it and there's some to spare, and then that goes to the national grid as well, where you get a small fee. You won't make millions out of it, but you might get a small fee. When the wind flows across the blade, what actually happens is that the air pressure on one side of the blade decreases. So cause the air pressure on one side of it to decrease. And then the difference in air pressure creates lift and drag. Okay, the force of the lift is stronger than the drag, and this causes the rotor to spin. Okay, so let's actually have a look at that diagram. And again, now, when you look at this diagram first, it might look deadly fancy, but if you actually analyze it, it's not great, because I'm putting in the parts I need to put in, but I'm trying to draw quickly, and I don't need major detail here. But what I do need to show is at least the blades of the wind turbine. What are the blades connected to? They're connected to the rotor. What does the rotor do? It spins because the blades have caused it to spin. Okay, then all of that enters in here into our what's it called? It's going out of my head now a second. I know I've written down here somewhere. The control box. Yes, control box. In fact, I better write that in now. So it all enters into that control box. Give me 1 second. This is why I don't write in front of you. I get obsessed with how tidy it is or not. Okay, so there's my control box. Essentially, the box that surrounds everything. It keeps it all in place, tidy, and all that sort of thing. All right, so control box. So where were we? Blades turn the rotor turns the gears, which are inside the control box. The gears, the gears generate this electricity using the electric generator. So they're spinning inside in this electric generator. That's where electricity is generated, as the name would imply. We have a high-speed shaft and a low-speed shaft, and that's where you're getting your gain of electricity. And then that gets pumped down or pushed down through the tower. and generates our electricity. So that's what's happening inside in our wind turbine. Now, you will also need an inverter. Okay, so the inverter is needed to convert the DC, the direct current voltage from the turbine, to match the AC voltage required in a domestic house. So we have to go from DC to AC, which is direct current to alternating current, okay, which is what we normally have in our house here. And I'll talk about that now in just a second. In this diagram, it's here in this diagram, so I'll come back to that. Just a few little things on the wind turbine itself before I go on to that control box and sorry, not the control box, the converter box. Control box is used to protect the inverter and the turbine in strong winds. Okay, concrete foundation is required for the tower. Naturally enough, these are very, very large structures. Concrete foundation will be required. And with that, planning permission is usually required or often required, particularly if the turbine interferes with the character of the landscape or the view, and actually there can be some sound problems in areas with these turbines. All right, so there is our diagram. So we have our wind turbine, wind blows, turns all the blades, we know what happens in there. The electricity that gets generated goes down through the turbine and gets connected to the house or to the grid, depending on which way you're going. If it's going to a house, they are collecting the excess here within the battery, but in order to use it, it must go into a converter box, and that's where it's going to get changed to AC, alternating current, and then it goes out and powers your TVs, your lights, your whatever it is you're having in your house. Charge your own phone, I suppose, which is all you seem to be interested in. But anyway, so once it's used then and the lights, or you have excess to spare, then that is sent to the grid. Okay. Oh, also, you'll be attached to the grid anyway, because sometimes you might not generate enough power for your own use, and that will need to give you power as well. All right, next set, or next item. And I spelled photovoltaic wrong there again. I'll put an A in there. I'm going to try photovoltaic, VOLTAIC. If I rub it out, you see all my little pink stuff will rub out as well, and I don't want to do that. Anyway, my red stuff. What is it? Right. A photovoltaic panel is a collection of photovoltaic cells, right? So we have singular cells, put a load of them together, a collection of them, okay, you have a panel, all right? And again, the more of them that you have, the better the chances of generating electricity, particularly in Ireland, and particularly in Ireland in the winter, okay? They are quite expensive though, which is why you would think that the full house roof should be made from photovoltaic cells to make it efficient, and yeah, probably should, but cost is often an issue with these cells. Multiple panels then are wired together to form an array. Okay, so you'll have one panel made up of cells, multiple panels become an array. The bigger the array, more electricity generated. Okay, makes sense. Now, what actually are they, or what do they look like, or what in the name of goodness is happening inside them, right? So here's our photovoltaic cell, right? And this time I actually spelled it right. Photovoltaic cell on the left and right, same thing, same cell. What's happening? First of all, the top layer, okay, is the layer we see. It's that bluey, blacky color that you will see on houses. And then there are 5 layers within the whole unit, okay? What happens is this middle layer contains positive and neutral electrons, okay? So far so good. Middle layer, middle tube, whatever you want to call it, contains my positive and negative electrons. Then the sun shines, or hopefully the sun shines. When the sun shines, right, the photons released from sunshine, they cause this middle layer to separate into positive and negative electrons. So negative electrons go one direction, positive go the other. Okay, and we need positive electrons for generating electricity. Okay, so that's what happens. That's literally what happens within the tube. Okay, so basically what actually happens in terms of writing it down, the solar panel uses particles of light from the sun. These are called photons. And again, remember, we need keywords all the time here, lads. Always write down exactly what it is, or the terminology, use the correct terminology. If you want full marks, remember that examiner has a list of keywords that they're looking for you to hit on. Anyway, so it uses photons, so the sun, to separate those electrons from the atoms. Okay. The process of separating the electrons causes the electrons to hit off a metal conductor strip on the outside of the PV cells, and this is what generates electricity. Okay. Again, though, like with the wind turbines, excess electricity can be stored in a battery or sent to the grid, and PV cells produce direct current, but an inverter again is needed to convert it to AC, suitable for domestic use. Okay, so fix something there now, sorry. There. Oh, not quite fixed, wrong color. Let's try it again. There. Okay. Now, near the end, and this is the bit that I nearly forgot. I was about to jump straight into local tradespeople and so on when I went, oh, hang on a minute, I better read that question again. And I did. And on reading it again, I discovered that they want us also to tell you or tell them how do these systems, oh, excuse me, make a dwelling more eco-friendly. Well, they reduce dependency on non-renewable methods of energy production. Okay, let's get rid of that because I didn't think that was that pen. Anyway, they reduce dependency on non-renewable methods of energy production. If you're using this, you're not also using petrol at the same time or oil or whatever it is to produce your electricity. And because you're not using those fuels I mentioned, they produce free and clean energy. This costs nothing to produce. Okay, you need the materials, but it actually costs nothing to produce. Now, because of this, no fossil fuels are burnt in the process, so they're not generating these fossil fuels. As a result of that, greenhouse gases are reduced because they're not using fossil fuels. No generation of harmful gases, such as carbon dioxide, because it's, again, no fossil fuels, no greenhouse gases, no carbon dioxide created, no waste product at all actually is generated. Okay. In fact, its waste ends up being electricity. And then it reduces the dependency on mains electricity. So that's a really important one. Some houses, depending on where you live in the world or where you live in the country, some houses can produce all their electricity using these methods. Others produce enough that they can sell it back to the grid. So the more that they send back to the grid, the less that the grid is producing using fossil fuels. All right, last part of the question was to say or give the advantages of using local craft skills when building the house. Now, excuse me, I did mention at the start that this is can be very, very waffly rubbish, sometimes written down. So try as much as you can to just put it in point form, and rather than just putting in 2, because I think they only asked us for 2, I put in a lot, but rather than just putting in 2 or whatever they ask you for, put in a few more points that are relevant are better than 1 or 2 points waffled away and talking rubbish. All right, so what do they do, or what does this do? This preserves traditional knowledge and skills within the area. That's important. Sorry. It also means that employment is generated locally. Okay, so we are able to generate employment locally because we are employing local people, just what it says in the tin. Because of that, families then can remain in locality and contribute to community life and events and schools and so on. Okay, so keeps a locality busy and efficient. And then the local workers will know where to source materials and more labour locally. So when you have a local worker, you will be able to source your materials and your labour. Oh, sorry, lads, I don't want that to come on me. Okay, sorry. And then the last and the most important one, there is no migration of workers, not the most important one, but one that is important. There is no migration of workers to other areas, and that leads to less traffic on the roads, and urban sprawl can be prevented, etc., etc. All right, guys, so that is that question, and there is a lot there. I don't like using the phrase, but I think it's important here. There's a lot to unpack. You're going to need to go through the solution. I suggest printing it out. Maybe looking at it, reading it, and then I suggest sitting down and redoing your own solution, okay, from scratch, from your head though. Okay, don't just copy mine, and then go and see what are you missing and what do you not have. All right, and the plan is to continue on doing these questions until we have that 2019 paper done. Okay, so we're getting there. That's question 6. Good luck with that. Send them in to me once you're done. All right, guys, thank you.